Show the delocalization of the negative charge on the benzylic carbon. So that's the benzylic carbon. It's got a pair of electrons, so therefore you have a minus charge at that carbon. Alright, so what could happen is that lone pair could form a second bond between that carbon and that carbon. Carbon can only have 4 bonds, so that means that this bond here is going to have to go to that carbon as a lone pair. So a second resonance structure would be where the lone pair is there. So therefore you have a minus charge there. And you have a double bond, 2 H's at that carbon, and then a double bond there, and a double bond there. Next. Alright, so that lone pair on that carbon could form a pi bond between that carbon and that carbon. So that carbon there has to give up that bond, so that bond goes to that carbon as a lone pair. So now the negative charge has moved from that carbon to that carbon. Yes? Alright, next. That lone pair could form a second bond between that carbon and that carbon. That means that this has to move at that carbon, forming as a lone pair. So now you have a lone pair at that carbon. So another resonance form would be this. So you have a lone pair there with a negative charge, carbon with 2 H's. Alright, next, that lone pair could form another bond between that carbon and that carbon. That has to go to that carbon as a lone pair. And so finally you form your next resonance form. So now the lone pair goes back to the benzylic carbon. So that structure is the same as that structure.